think not this one. Should be this one. Where is it? Object oriented, forget it. Picture. So it should be this one. Channel 5, yes. I think I already gave this one, yes. We finished it. We finished this one. Total. Okay. Let's take this one. Let's return here. We mentioned here that we have 3 types here of naive Bayes or Bayes classifier, multidimensional naive Bayes classifier, okay, Bernoulli naive Bayes classifier, Gaussian, or multinomial. Okay. Usually we take this one. Last example actually for this one. Distribution of some data, and we use the normal Bayes decision rule. We first calculate the posterior probability, then we get, for example, if we have 2 categories, then we will have 2 posterior probability results. Then we will see which one have greater value. Then it will be the category that we will select or classify to it. For the multinomial naive Bayes, we have little bit differences here. We speak about frequency of some words in some documents. So it's usually used with document classifier. So document usually have many keywords, and depend on this keyword and the frequency of the words inside the document, we can classify this under specific category. For example, about the subject, is it science, is it math, is it linguistic, and so on, depending on the frequency of some words. Here we have this example. Last example was us. It's about this type of naive Bayes, which is depend on multinomial or nomial, something like this. Doesn't matter. So we speak about what? Document and topic. Classify document into topic. Here in this example, we have 2 categories or 2 classes, 2 topic. C, it's for China here, and J for Japan. Okay, so as you can see here, we have this data set. It's have 2 parts: training and test. So we will use this training set. Training set, as you can see, it's already labeled because we speak about which type of learning? supervised learning. The data set, each document, document 1, document 2, document 3, each document, it's already have label classified. Okay. Of course, we could have many other words in the document, but this the keywords that we will use it to classify. Okay, I will open first attendance for you. Six, 4, 5, 2, 9, 1. This is that code. So, depend on this training set, we have to test this document, document number 5, and classify it into C or J category. For multinomial or nomial, we have little bit different here. We use same rule, Bayes rule, but for the calculation, we have little bit different here because we depend on the frequency of the words in each document. Okay, so we will use this rule. First of all, we need this data to calculate it. Probability of C, probability of category C. Here, calculate the probability of C and the probability of J from this data. It's easy. How to calculate the probability? Probability of C. It's equal what? Yes, so probability of a specific category. Have this category in the data set, divide by the total number. Yes, probability of anything. Be to the or divided by the set, the whole set, or the whole number of categories here, like the blue and black or red balls examples that I give to you. So probability of C, how many times we have C? 1, 2, 3, divided by the total number, which is 1, 2, 3, 4. So divided by 4. So it's 0.75. Okay. Probability of J. 1 divided by 4. Why minus? Okay. Because we have only 2 categories. Yes. It's okay. Yes. It's correct. Or 1 divided by 4. We finished the attendance, yes? Everyone already registered the attendance? Okay, I will open second one, not now, when we start second one. So it's 0.25. Okay, what else we need? We need probability of Chinese given Chinese word given category C probability. So how the conditional probability calculated here? So probability of X, any X, given Y or class Y or category Y, generally for this type, okay? It's applicable for, so when you see any document example for classifying document, you will use this one directly. It's number of repetition, calculate how many times it's repeated, of the expression X or word X. For example, China word. Okay? In the line, in category Y plus 1. Why we said plus 1? To avoid the multiplication with 0. Because at the end, we will multiply the repetition, the probability of repetition of each word with each other for a specific category. So if one word, it's appears 0 times in the document, 0, this means we will, when we multiply it by other probabilities, the whole result will be 0, and we don't need probability of 0 for a specific category, because this means we remove the whole category. So here we don't have Japan. The repetition of Japan 0, yes. We will add for how many Japan we have 0. We will add for all the expression or word count here. Okay, so we have here number of repetition. So, okay, word X, how many times it's repeated? Plus 1 divided by. So division we have here. Number of all words in the line in category Y means here we have, for example, category C. How many words we have? A plus number of different words in data taught. What's the meaning? The training data. What's the meaning? Number of different words, not repeated word, different word. Okay, what's number of different words here we have? We speak about the training data in the whole training set. So for example, here in this one, how many different words we have? 1, 2, 3 in the whole training, we say. 1, 2, 3, 4, 5, 6. So this number will be 6. Okay. So let's see how to use this one. Okay, so first of all, we need what? To classify this one. So probability of this testing will be C with the testing data, or G or J with the testing data. This one, we need to calculate it. Okay, so we need to calculate probability of category C for the testing data or category G for the testing data. So how to calculate this one? It's equal probability of category C. This one equal probability of category J multiplied by probability of each word with the category. So probability of Chinese with category C multiplied by probability of Chinese another time, everyone, because repetition here make difference. So probability of Chinese another time with category C another time, then Tokyo, then Japan. Of them, the probability will be 0. So the result for this category, the whole will be 0, but we don't need its probability to be 0. Actually, its probability must not be 0. That's why we add 1. So, because there's no place there to write it. So, if you remember, we have Chinese in the testing. Yeah, I think we have another E. Repeated 3 times. Another time Chinese, another time Chinese. Then Tokyo. Then Japan. And we need to classify this one. So to classify it, we will say we need probability for category C with the test data, the whole test data. This is the test data. It's equal. Probability of the Chinese itself, we calculate it, multiply by. So for the document base, to classify category, we if it's repeated, we need to get its probability. So in the test category here, in the test data, we have Chinese, so probability of Chinese with category C. Another time Chinese. With no, another time multiplied by probability of Chinese with category C. Third time probability of Chinese with category C, then probability of Tokyo category C, probability of Japan with category C. Then we will get number. Same issue, we will go for probability of K. K means Japan here, yes. With, but we make it J, need to differentiate between the class Japan and the word Japan, okay? So same issue, probability of Japan multiplied by the word China with category G. The word China with category G. The word China, why 3 times? Because the test data have 3 times China, multiplied by Japan and so on. Okay, this one, we already calculated it, 0.075. This one, how to calculate it? It's equal. How many times we have this number of repetition of the X here what? Is with the specified category, a plus 1. Okay, how many times we have Chinese with class C? Calculate how many times. We have 1, this is category C, yes. So in category C, we have 1, 2, 3, 4, 5. Yes? So 5 plus 1. This is the rule. Yes? How many times it's repeated with the category? Plus 1. Divide by number of all words in the lines in category Y. How many words we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 plus how many different words? Different words, not repeated words. Here's the total number of words. Here, 1, 2, China, Beijing, Shanghai or Shanghai, and Macau, but not for category, not for the category. Here, for what? In the data, in the whole training data. So continue, don't stop here. 4, 5, which is Tokyo, 6, which is Japan. So divided by 8 plus 6. Okay, so probability of China or Chinese with category C, it's equal 5 plus 1 divided by 8 plus 6. So it's equal 6 divided by, okay, another time. Probability of, we finish China with category C. Let's see probability of, we need China, Tokyo. Tokyo with category C, it's equal. Okay, how many times we have Tokyo here? 0. You have Tokyo here? How you calculate it? Well, we speak about category C. The only one we speak about whole data set, this number. Okay? So it's 0. Yes. Plus 1. If you did not say plus 1, so this probability will be 0. If probability of Tokyo with category C 0, here this one 0, so anything multiplied by 0 will be 0. So at the end you will not have probability, you will have 0 here. And this, if one of the how many times we have Tokyo, yes, or different word, sorry, different word, which is 8 plus how many different words? 6. So this one always for category C will be same. So divided by 14. This how many words? 1, 2, 3, 4, 5, 6, 7, 8 for category C, plus different word, which is 6. 1, 2, 3, 4, 5, 6. Yes. So this one you will calculate it one time. It will be same for always for category C. Here's the difference. So it's 1 divided by 14. What else? We need to calculate the probability of Japan with category C. It's equal. How many times we have Japan here? 0. Plus 1 divided by 14. We already calculated it. It's 8 plus 6. So it's equal 1 divided by 14. Okay. Let's continue now for probability of with category J. It's equal. Yes, how much? Okay. We speak about this category, yes? So how much? How many times we have Chinese here in category 1 plus 1 divided by how many words in the category? 1, 2, 3. Plus this one will be same for all the categories. Why? Because it's different word in the whole training set. So it will be same plus 6. So this one equals 2 divided by 9. Yes? Probability of Tokyo. We need Tokyo and Japan. Tokyo with category J. It's equal. How many Tokyo we have? Here, 1 in category J. 1 plus 1 divided by 9. You don't need to calculate this one with everyone because it's number of words in the category plus different words in the whole, different, not repeated, words in the whole data set. Same issue. So it's be same, yes. Probability with category J, it's equal 1 plus 1. Why 1? We have Japan 1 time plus 1. Why plus 1? Because we need to avoid multiplication with 0, probability of 0, divided by 9. Okay, so after you calculate all this calculation, okay, so we have probability of China with C, it's 6 divided by 14. This one, we calculate it. Then for the test, multiply by probability of each word in the testing data. Here, the testing data. Probability of Chinese multiplied by probability of Chinese with the category multiplied by probability of Chinese with the category multiplied by probability of Tokyo and Japan. As you can see, the multinomial or nomial knife have little bit differences when we speak about repetition, because we speak about repetition of words. So here only the different. How to calculate the probability of a specific word for a specific category. Okay. Category C, China was category C. So we already calculate it here. This probability of China, this probability of Tokyo, probability of Japan, so it's equal. Of course, you remember the original rule divided by something, yes? Divided by probability of China, for example, but here we don't have only China. we have China, and we have Tokyo. So because the one here at the division, it's same like this one. You remember the knife? We said what? We avoid it because it's need a lot of calculation. We mentioned it when we mentioned here the general rule for the knife. Let me remember where we mentioned it. I think here. Yes. Okay, so we said this one. Will not affect Bayesian classifier. It's knife Bayesian classifier because it's become very simple. Okay, so we have to result for probability of category C. Where is it? Here. With the test data and probability of category G. With the test data, this one 0.0003, this one 0.001. So the test data under which category will be categorized? Here, it's greater than probability of J with test data. According to our classifier, we take the highest probability. It will be under category C. So the result here, this one will be category C. Okay, we finish this one. Next subject, subject will be much easier even. Let me just stop this one.